Welcome. Today we will discuss about an solved problem of a composites wall in thermal heat conduction. So here is the sum is a furnace wall consists of steel plate of 20 mm thickness, thermal conductivity 6.2 watt per meter Kelvin, lined on inside with silica brick 150 mm, thick of thermal conductivity 2.2 watt per meter Kelvin, and the outside with magnesia brick 20 mm thick of conductivity 5.1 watt per meter Kelvin. The inside and outside surfaces of the wall are maintained at 650 degree Celsius and 150 degree Celsius respectively. Calculate the heat loss from the wall per unit area. If the heat loss is reduced to 2850 watt per meter square by providing an air gap between steel and silica brick. Find the necessary width of air gap if the thermal conductivity of air may be taken as 0.03 watt per meter Kelvin. So let's consider this is the given data of the problem, and we having the four part of this composite wall furnace wall material, and the properties given properties are length 1, thermal conductivity of part 1, length and thermal conductivity of part 2, length and thermal conductivity of part 3, and the inside and outside temperature are represented as T1 and T4 is given in degree Celsius, so we converted into as an Kelvin, and given heat transfer rate is 2850 watt per meter squared, and given air gap of the thermal conductivity is 0.3 watt per meter Kelvin. So we need to find the heat transfer rate and length of the air gap. So basically we know that heat transfer rate is equal to del T by R. So del T is a T1 minus T2 by R. So R is a resistance, the combined resistance value is R1 plus R2 plus R3. We know that the resistance R formula is L by Ka. L is the length, K is the thermal conductivity, and A is the area of the particular slab. So we substitute from all these categories from our given data. We get it the R value, and finally we substitute this R value into our temperature difference value. We get it the Q of the given problem is 4602.6 watt per meter square. And let we go to the second part of the given problem is 2850 Q watt per meter square. And Q given is del T by R1, and 2850 is we substitute from the given value, and del T by R1 is del T is 500 and R1 is we need to find out. So from the given problem we know or we need to about the length of the air gap. So for this length of the air gap, we first need to find the resistance of the air gap is equal to R1 minus R, and R1 is a 0.1754 and R is a 0.1086, and R air gap is 0.066 Kelvin per watt. So we know that resistance formula, basic formula is equal to R is equal to L by Ka. So in the R gap of air is equal to L gap of air by K of air into A. So from this equation we know that the thermal conductivity of air into area into resistance of the air is equal to, we get it the final length of the air gap is 1.98 into 10 power minus 3 meter. So finally once again I will summarize this problem is we substitute these all values, or first we need to find about the heat transfer of the all three slabs, and we get it this heat transfer value, and comparing with the given heat transfer to the consider as a slab 1 and get it this R values, and substitute these all values, we get it the resistance of the part 1, and finally we need know or we need to get about the resistance of the R gap is R1 and minus given of the R gap is given or is a total given, and we get it the final length of the air gap is equal to the formula of resistance of the air gap into area into thermal conductivity of the air. Thank you.